Welcome back, everyone, to the Python tutorial seminar series. I hope you all had a good holiday and conference season and are ready to learn more in 2021. So before I begin, we need to review the code of conduct. So just so you know, by joining this Zoom call and participating in this tutorial seminar series, you've agreed to adopt these values and engage in respectful communication only. If we see any inappropriate remarks in the chat, you'll be removed by one of our co-hosts. In this and the next session on February 10th, we'll be learning how to create a Python package and the basics of how to use built-in packages. This knowledge will prepare you to best learn any other packages that could be useful in your workflow. Creating a package may sound daunting, but I'm hoping to show you that it's just a little bit more than sensible code organization and structuring, which I hope you were doing some of in your previous coding languages, just for your own sake. I've seen many scientists sharing their code, which is really great for reducing redundant work, but it has some challenges, especially that it could be hard to track. Say the original author finds an error somewhere in their analysis in a file that has been shared with many other scientists in their field. How do they track down every single person that now has a copy of their code to make sure everyone's aware of this issue or of this improvement? So Python package management makes this much easier for us. So let's refresh what we've done so far. It was about 2 months ago, so maybe you're a little rusty. I know some participants watched the previous videos just as a little refresher. I think that was a great idea. We had written our first ever Python function, and it computed wind chill index. And at the end of the session, we pushed our work up to GitHub for the first time. Today, we're going to move our functions and code blocks into a new Python package and then import that package into our analysis scripts, windchill comp.py from last time, and our new script that we'll work on today, heat index comp.py, which computes the heat index. The scripts will be much easier to read and write, and our functions should now be easier to share. So on the screen now is the formula for heat index. It's basically a power series expansion in 2 dimensions with a bunch of constants. And I know it seems like a lot, but we'll give you time to copy it down when we actually write the function. Again, the function is available on the tutorial website. It does have the copies of the code to look at there as well. And if you don't have every single one of the numbers in these constants correct, it's going to be okay. This is not a lesson on the science behind heat index. It's a lesson on Python packages. So as long as our code runs, even if our answers are a little out there, it's going to be okay. So as I just said, our functions and commands are all going to be available on the website or our tutorial cheat sheet. Will someone from the Xdev team post that in the chat now for everyone's convenience? Feel free to refer to that as we move through today's lessons. And also, I'd like to remind you of 2 other resources, our Python documentation and Stack Overflow. Sorry. Not. Okay. This seminar is only 1 hour long, so I will not be stopping the lecture to give individualized attention. Hopefully you can find help in the chat from fellow attendees and maybe some of the co-hosts, but ultimately, if you have technical issues, it might take a little bit more time to diagnose that. So please just relax. It's only an hour, and there'll be the recording, the website, and one-on-one assistance available afterwards if you do need it. Okay, let's get started and open up our terminal. Okay, hopefully you have now navigated to your favorite terminal. So within your terminal, it is now time to move into our directory, which, if you've been following my namespaces, is within your documents folder and is called Python_tutorial. Let's also activate the Python tutorial directory with conda activate and then the name of your environment. Remember that this environment is not explicitly tied to the directory, as Kevin referred to at the beginning of the session. They do not have to have the same name. They just both have the same name in this case because they correspond to the same project. Okay, you can now see we are no longer in our base environment. We're now in Python tutorial. Okay, let's jog our memory again and see what we've done so far with a ls to list everything that's here. And you'll see we have our one script, windchillcomp.py, and we have a data folder. Inside of data is just our single text file. You can go into there and do an ls again to check. Okay, so the first thing we're going to do is make a copy of windchillcomp. So the way to make a copy is cp, the name of the file that you're copying, and then the location to which you'd like to copy it. So we're going to copy it to heatindexcomp.py. We're copying it here instead of just starting a brand new script because you'll notice that much of the analysis is going to be very similar. And so it's very helpful to just kind of start out with some of the code base already there. Okay, if you do an ls, you can see that our new script is there. And let's add this to Git. Git add heatindexcomp.py. And we'll do our first commit for the day. Git commit -m for message, and then our message will be copying first script to start second. Okay, let me maybe make this a little bigger so you guys can, hopefully that's a little easier for everyone to see. Okay. Okay, let's jump right into writing our second Python function. So open up heatindexcomp with nano or whatever your favorite text editor is, and then the name of your script. Okay, and before we make any changes, we'll just quickly review the structure of this file. So you'll see that we have our columns and types dictionaries, and then we have this whole block of code, the data, the reading the file, and our with open statement. That's all for importing the data. Then we have our function. Then we run our function, and then down here we have printed the output of our function. So the first thing that we're going to change is the function itself. It's right here. So instead of computing wind chill temperature, we're going to compute the heat index. Again, change the name of your function. And the input arguments of our function are no longer temperature and wind speed. It's now temperature and humidity. Okay, I'm going to go ahead and delete all of these lines so that we can start fresh. Okay, so remember to indent 4 spaces inside your function or all indented blocks. So 1, 2, 3, 4. And I'm going to go ahead and just start listing the values for all of the constants A through I in the formula. You can follow along with me, but maybe you want to type a little bit faster. And this is a time that I really recommend looking at the website so that you can see all the numbers at once. So A is negative 42.379.234. I'm not going to read all of the numbers out loud, but you get the idea. Okay, about halfway through our numbers. Okay, hopefully I got all of those right, but see, I already see an error. Again, I'm not going to spend too long trying to track those down. Even if my values look absurd, just remember that this is not a lesson on the science behind heat index comp. Okay, so then the next line of our function, again, indented 4 spaces, we have to convert humidity, our relative humidity, which is actually input as a % value. We want the decimal version of that. So just go ahead and create our new variable RH, that is humidity divided by 100. And then on the next line, we're going to type the equation. So I'm going to do HI for heat index equals our first term, which is A plus B times T. I'm going to put spaces in between all of the operators and the variables. That is best practice and is, generally a little bit easier to read. C times our humidity plus D times T times humidity times T squared. Remember that the double asterisk is not multiplication. It is the raising it to the power. Okay, so I'm actually going to split up the equation onto a few lines, and you can do this with having the parentheses around the entire function and the plus sign. And then I have to indent this either an extra 4 spaces or underneath the A. I think I'm going to try under the A just to, but if I have a mistake, we'll see that and go in and fix it. Okay. This time humidity is squared. This time temperature squared. Okay.
Julia, I think you've already got a T squared term, so that G term I think is missing something. Maybe it's RH times T squared.
It is. Thank you. It's a lot of values. Again, maybe hopefully it's not too hard for everyone to follow, but if it is, as long as what you have is syntactically correct and runs, we will consider it a win for today. Okay, and this is the last term.
And that should be RH squared, not just R.
Yes, thank you. Thank you for helping me catch errors before the error message pops up. Okay, and then the last line of our function, again, indented 4 spaces, we need to return HI so that this value is available as output from our function. Where the constants A through I, we will not be able to just call up in the rest of the script. Okay, so I'll leave this up just for a second so everyone can catch up and just kind of talk a little bit about heat index. So it's also known as apparent temperature, and it uses assumptions about vapor pressure, wind speed, your skin's surface area, radiative properties, and even the average human sweating rate, just to kind of make these assumptions and then a regression analysis. And that's how we ended up with this function and these particular constant values. Okay, hopefully everyone has this now. I'm going to go up to the very top of our script and edit the columns and types dictionary. Because you can see now in this function, we are not using wind speed, but we are using humidity. So we will need to call those values out when we read in our data file. Okay, so delete these last 2 keys in columns. And this one we'll call humout. That's what it's called in the text file. And it is mapped to index 5. And while we're here, we'll go ahead and also grab the value for heat index that is in the original text file so that we can compare it and see just how many of those constants we got correctly based on how close our value is to it. Okay, and also in our types dictionary, we need both humidity out and heat index, oh, I was on the wrong line, to also be a float. So here, instead of wind speed, humidity out is a float. Instead of wind chill, heat index. Okay, so this is what our inputs for the dictionaries that we use to read in our text file will now look like. Okay, and now all of this reading the data file looks the same. We are computing our function. Let me delete these extra lines. And now when we actually call up our function, we are not computing wind chill index. We are computing heat index. Again, change the name of the list we're initializing. Change the values in your for loop. The key that we're calling out of our dictionary. Basically, all references of wind speed are now humidity out. All references to wind chill are now heat index. Okay, and now we have to change the last piece of the script, which is the printing. So I'll scroll down to there. So the comparison of data, you'll see now our name here. where we have wind chill is now heat index. And again, change all references to match our current analysis. So wind chill. Here, this is the one in our dictionary, so the original value. So heat index, and then the one from the list that we've just computed. Heat index. So HI instead of WC. And hopefully this feels a little bit tedious to you. If it does, you're definitely going to appreciate the rest of the lesson. Going through and changing all these values. Again, if you have to do it just once, it's not that big of a deal. But say we had 10 different analyses we wanted to do, all based on the same data file that followed this similar structure, there's definitely a much faster way to be able to do that for each thing we wanted to calculate, each variable, than going through this and finding all references to one and replacing it with the other, because you can miss them. Sometimes your text editor helps you out, but generally we want to have to duplicate and replace as little code as possible. Okay, so let's exit this, save it, and run it, and do one last check for any syntax errors if we get any error messages that come up. Okay, yes, I'm taking my changes, and then I'm executing my script. Okay, I'm lucky that mine work. Well, maybe not lucky, but you know, we all have some syntax errors sometimes. If you have an error, hopefully the message is informative enough for you to track it down. Okay, I'm going to clear my terminal just so that I'm up at the top, because I was hearing that some of the Zoom toolbar sometimes hides the last line of my terminal. Okay, so now that we've actually changed our script so that the body of it matches its name, let's do another git commit for it. So git add heat index comp.py and git commit -n for message updating new heat index script. Okay, so that's kind of the first leg of today. We have basically repeated all of the work that we did in our last session way back before Thanksgiving, but we just did it way faster. We took about 15 minutes to do it, where before we spent the whole hour on that much work. So hopefully that was a good refresher of everything you've learned. And now we get to kind of get into the meat of the lesson. So open up one of your files again, and we're going to begin to address the duplications that you see here. So I'm going to start with wind chill. Okay, and we're going to look at all of this code that is used for reading in the function. Let me see. So we start from initializing our data variable down through our data column appending. Now all of this code is used to basically do the same thing in both scripts, and we don't need that. So I'm going to go ahead and copy it. So it makes it it's a little hard sometimes if you don't get lucky with the way your terminal breaks it. Sometimes you can use like a Control Y, but then if you don't have clipboard abilities enabled, that won't always work in your other file. So I'll just copy what I can here from initialize my data variable down to for columns and columns, and I'll have to add the extra code. Okay, and I'm going to exit it out. Okay, so now we're going to create the file to house this code. So I'm going to call it read data. And remember, to create a brand new file, do touch and then the name of the file. You can do an ls to see that it's there and go into that file. Okay, so the first line of this file is going to be our new function definition. Our function is going to be called read data, and it's going to have the inputs of columns, which is our dictionary, types, which is also a dictionary, and you'll see here I'm setting it equal to an empty dictionary, and this is called a keyword argument. This means that you do not always have to enter this value. If you do not enter it when you call up your function, it'll be assumed to be this value. But say we entered what our new types dictionary is, it'll be overwritten. And we're going to do one more keyword argument, which is for file name. And then put the path, no spaces here, put the path to your file. So it's in data, and it is called wxobs 2017-0821. So what this means is that we do not have to enter our file name every single time that we call the function, because in this lesson, it's always the same file name. But for any file that has similar structure, this exact same function will work. So it maintains the versatility while kind of reducing the amount of work that you have to do when you're calling up a similar workflow repeatedly. So if there's an answer that you use more often than not for one of your inputs, it's a good idea to make it a keyword argument. So again, keyword arguments can be called in any order and don't always have to be called, but they have to be called after all positional arguments. So the columns input always has to be first. Okay, and now within our function, go ahead and add our code. And I'm going to go up to the top and make sure everything's indented correctly. So the first thing we do is we initialize our data variable. Put it in 4 spaces, 1, 2, 3, 4. 1, 2, 3, 4 for our data dictionary. We still are reading in our columns dictionary as so 1, 2, 3, 4, 1, 2, 3, 4. And we no longer need to specify the name of our data file. So I'm going to indent still this comment, and I'm just going to go ahead and delete this line. 1, 2, 3, 4 for our with open statement. 1, 2, 3, 4. I'm going to capitalize that just because it looks nice. 1, 2, 3, 4. 1, 2, 3, 4. And then indent these lines as well. 1, 2, 3, 4. Okay, and now I have to add the lines that I'm missing. So I'm just going to go ahead and do that now. So you can see you get a lot of spaces once you have multiple nested blocks. Okay, that looks good to me. So the body of this function is the same as what we've seen before. But don't forget to add your return statement. And we're returning data. Okay, hope that made sense to everybody. We are now going to add one more thing to this function before we exit though. And this is called a docstring. So we'll go back up to the top. And before we actually begin, we're going to have two lines of triple quotes, 1, 2, 3. 1, 2, 3. And within these quotes, everything you write can be treated as a comment, but across as many lines as you need. So this is a way of clearly documenting what your function does, what its inputs need to be. That'll be a huge help for future self. But without the restrictiveness of the one-line hashes. So it just looks a little bit nicer, and kind of the best practice for it is for the first line of this to be what your function actually does. It reads the data from CU folder, weather station, data file. And then you also want to list the parameters of your function inputs, which are columns, types, and file name. So we're going to go in and describe what each of these is. A dictionary, mapping to column indices, basically the same thing, but mapping to the types to which you want to convert your data. And the file name is a string path. So you'll notice that for each of these, we made sure to mention the type that the data is, so that you know not to enter a list instead of a dictionary or a single value, because the function will fail, and if we don't document it, it might be a little hard to find out why. So this utility and parameters are standard information that will help you later on, but there's not any like one rule or set of requirements for what your docstring has to look like. This is just what we recommend. Okay, and with that, I am going to exit this file. Save it. And do a git add now that we have our new module. So git add read data.py, git commit -m for message, adding new read data module. Okay, so now let's actually use the function that we just wrote. And perhaps what's more interesting about this is that we're going to use a function that's written in one file in another file. So I'm going to start with windchill.comp. And I'm going to show you how to do this. And then I'm going to stop sharing my screen and give you the opportunity to make the identical changes in your heat index comp.py file. So the first thing we do is we import read data, from read data, import read data. So you want your import statements to be at the top of the script. And what this is saying is from read data, which is our module, it's just the name of the file, but without the .py extension, and then import this specific function that we want to use, which is read_data. And now we can go in here and delete all of the duplicated lines that we don't need because it's in our module. So go ahead and delete everything from initializing your data variable to the end of this block where we append data. And what we're going to replace it with is the comment for what we're doing, read data from file, and then our function call. Types equals types. So you can see here we've overwritten that one keyword argument types. And this read data function will work just as if that function was written earlier in your file. Okay, I'm going to exit this. Yep, sorry. And run it to make sure I didn't have any syntax errors anywhere. Oh, sorry, I did not mean to run. I meant to run Windchill comp. Okay, and it still works. So now I'm going to stop sharing my screen while I make the same changes to heat index. And then I will share my screen again and you can compare what your script looks like to mine. Okay. And I believe Kevin said he would pause the recording during this time. So if you're watching this on YouTube or on a video recording afterwards, you should pause the screen for the video for however long it takes you to complete this step.
I'll actually keep the recording going just because the recording also includes what's in the chat.
Okay. Okay, so I have now done the same thing to our heat index comp file that we did to Windchill. You'll notice the only changes are our import statement at the top and our function call instead of those many lines of code that we originally had. Okay, I'm going to exit this and run the code. And it works as expected. Good. Okay, so now let's do a git status. So you'll notice something new here. So we have our two modified files that have previous versions that already exist in the Git repository, but you'll see we have this one completely untracked file called PyCache. So what is PyCache? Basically, it's a directory that Python makes when you run a Python program with the import statement, pulling in the code from somewhere else. It kind of stores that compiled code so that the next time you call that exact function, it can run a little bit faster. The interpreter just learns the bit code and stores it in a cache here, which is PyCache. As a user, you can usually just ignore this this folder and this function. It's there, it's great. If you delete it, it'll just be regenerated. But we don't want it in our Git repository. We don't want it showing up as an untracked change every single time it's recompiled. So we're going to go ahead and create a Git Ignore that is going to tell Git to ignore this file. So to create a Git Ignore, we're just going to create a new file with touch.gitignore. And then you go into it. And we just have one line, which is the only thing we want to ignore. PyCache __ py cache __ backslash. Okay, now we can exit this. Do another git status, and you will see that PyCache no longer shows up, but Git Ignore does, which is fine because once we commit Git Ignore, it's not going to keep showing up every time we run our code. We do a clear, so I'm at the top again, and we are going to do that, just that. We're going to do git add .git ignore with the commit message ignoring PyCache. Okay, and now if you do a git status, you'll see we have two files now. And instead of adding them each individually, we can actually do git add -a to add both of them. Oh, it's telling me that is unknown right now, even. So I'm gonna ignore that and just add them both, I guess.
Yeah, someone pointed out that I think a more recent change to Conda or Git made it a capital A.
Oh, okay. So we could like this.
Yeah.
Okay. So gave me no messages, but didn't do anything because I already added them. If you do a git status, you see they're modified but not committed. And let's do our git commit message. This is refactor scripts to use new module. And git status, we're all clean. So congratulations, we have just refactored our code to remove a redundancy, but we still have some repeated code though. Look at the printing block in both of your functions. I'm going to open it up and scroll down to where we printed. And you'll see this block of code was a little redundant. So we're going to copy this and create printing.py and do much the same thing that we did with our read data. Okay. Touch printing.py. Nano printing.py. Okay, so this time our function is going to be called print comparison. And we have the inputs of name, which is our variable name. It is the wind chill, it is the heat index. It is going to be the string spelled out the way we want it to appear in the top of our table. Okay. Dates, times, those are the date and timestamps corresponding. Original data and computed data. And then go ahead and add our code from before, and we'll go in and indent everything as well as making sure that it is consistent with the input arguments that we are using for this function. 4 spaces, 4 spaces. Okay, so here, this is our first change. We no longer want to have this heading always say Windshell. We want it to now be part of the string imported from our input argument. So actually the first thing we have to do is put a little F at the beginning of the string because we're doing F string formatting now. And so now we can do name. This will make it pull in the string that we give it. And we're going to do dot upper so that it's uppercase, it matches everything else regardless of the format to which you wrote the string in your function call. Open close parentheses because upper is a function itself. And then do this colon greater than 9. This is similar to the F string formatting you see at the bottom. It's going to make sure that the number of characters that you use is limited so that our columns still match up. Now do the same thing to replace the second Windshell. Okay. Let's see, is this, I think we just want 1 space here. Okay. So again, indent this print statement here. Our zipping of the data. We are now zipping what's input to us, so we don't have to pull it out of the dictionary here. Dates times this one from the dictionary is original data. And the one that is itself just a list is computed data. Okay. Here, instead of having this be variable specific, we can just leave it as original and computed. And again, indent our for loop. 1, 2, 3, 4. Same for our difference. It no longer is variable specific. Time. Print original, computed, and the difference. Okay, and this one does not have a return statement. So the only new functionality that we've just introduced is with the name.upper or string.upper, which just capitalizes all lowercase letters in a string. And as before, we're going to add a docstring to this function. So again, triple quotes to open and close your docstring. And within those quotes, the purpose of our function, it prints a comparison of 2 time series, which is the original and computed. And we have our parameters. Name, dates, times, original data, computed data. And then we'll go in and describe what each of these is. So a string name for the data being compared. And we'll just make a little note that it is limited to 9 characters in length. Dates is a list of strings representing dates for each data. List of strings representing times for each data. Original data is just a list of our original data. And then I'll put in parentheses that every element in this list is a float. So it's a list of floats. So again, you can see that we make a point to specify the types as specifically as necessary and as possible. Okay, so now we can go in and edit our scripts as before. Okay, I'm going to edit wind chill and follow along, and then we will independently edit heat index. Okay, so we have one more import statement. So now from printing, import the function print comparison. Okay, and now down at the bottom where we print our function, run the function, we print our function, we can go ahead and delete all of these lines and just do a simple function call, print comparison, and then all of our inputs from it. So this is going to be wind chill. And then for dates, it's taken from our dictionary. Times is taken from our dictionary. Original data is the wind chill from our dictionary, and the computed data is just our list. Okay, I'm going to exit this and run it to make sure it works. Okay, we seem to be all good. I'm going to stop sharing my screen for a second while I make these same edits to heat index. Okay, so instead of that big printing block, you now have one line, the function call for print comparison, and these are the inputs from it. It's our string, and then date, time, and heat index, the keys from our data dictionary, and then our string heat index. And at the top of your file, you'll see we have a second import statement. Those are the two changes that hopefully you were able to make on your own.
Julia,
okay, I'm going. Mm-hmm.
I just noticed that in that heat index file, you have the data dictionary initialization above the read data call. You can delete that.
Oh, yes, sorry.
Yeah, that's okay. I think you just forgot to delete those lines.
Yeah, I just missed some. Okay, thank you. If you still have those lines in your code, also please delete them. They are not really doing anything. Okay, so I am now going to exit this and run it. Okay, all good. Okay, I know we're at time, but we are almost done. We have one last important change to make, and that is to make a third module called Computation.Pi. So far, we've separated out the concepts of data input and data output, And now we're going to put our data analysis into its own one. So I'm sure you can already imagine what this workflow is going to look like. We're going to copy over our functions into our new file, import them, and then go and edit those files. Okay, so I'm going to first create our file with touch computation.py. Do an ls, you can see it is now there. And I'm going to go and grab our function from Windchill. Okay, it is from here, def compute Windchill down to return WCI. I'm just going to copy it. And now I'm going to go into computation. And I'm just going to go in and paste it. So we don't have as many changes we have to make this time, since our function is already, it's already a function. We're not creating a new function, but we do still want to add a docstring. To better document this function. So compute the wind chill factor given the temperature and wind speed. And here we can make the little note that this function is not valid everywhere. It has a limited range. And then we will add our parameters again, which are T and V. So T is the temperature in units of F. So maybe you can see that specifying the specific units of your input and the type of your input are both very useful things to have specified in your docstring. Okay, great. And now we can go and copy our heat index function as well. Save changes, open up heat index comp. And I will copy all the way from the define function to the return function. Okay, so under the Windchill, we are going to add our new function. And it is always a good idea to have 2 spaces between 2 functions in your module. And again, the only change we have to make here is adding our docstring. Which the purpose of this function is to compute the heat index given the temperature and humidity parameters are T and hum. Okay, that's all we have to do to create this new file. So I'm going to go exit and now make the changes to Windchill comp to use it. So we have our third import statement from computing or from computation, import compute Windchill. And now you can just go ahead and delete the function. And that's all we have to do because our function call here looks exactly the same. Okay, and now go ahead and make the same change to heat index. Okay, this is what it looks like. You can see that our script is, I would say, a lot easier to read, especially since I don't have to do any scrolling to see what's happening here. I see the import statements. I see our dictionary initializations of columns and types. We just read the data in one line. We take 3 lines to run our function, which there's a way to do this in one that we will show you next time. And then we print our data in 1 line. I think it's very nice, succinct, easy to follow, and easy to make a third identical script too, which again, we will do next time. So again, let's exit this. The only changes you made were adding a third import statement and deleting your function definition. We can run it just to make sure it works. It's great. And we will do a git add to, so I'll just do a git status and see we have, oh, did I not do a git add after printing? Okay, well, we will do git add all and a git commit with the message adding printing and computation module. Git status. Okay, that's great. Okay, so just one little file cleanup to do is typically you want to group all of your modules into one directory together. So if we do an ls, you'll see we have 3 different ones, and we're just going to make a new directory to house these. Make mkdir for make directory, and I'm going to call it mysci. And we're going to go ahead and do a git move of these modules into this directory. So git move read data.py to mysci. Git move printing.py to mysci. Git move computation. Okay, let's do an ls. We can go in to this directory, and we can see we've got our 3 modules here. Now, to officially make it a package, it needs to contain an init.py file, which is usually empty, and in our case is empty. It just officially tells Python that this is a place to look for your modules. So we'll just do a touch __ init __ .py. You can see we now have 4 files in this directory. That's great. That's all we have to do to turn it into a package, but we actually have to do one last edit to our functions or to our scripts. It'll be super quick, but we have to change the path of our import statements. So go into Windchill. Oh, I think I just created a new. Oh, I have to move out of here. So let me make sure I didn't create that. Okay. Make sure you move out of your mysci directory so you're back up where you can actually enter your scripts. Okay, so now instead of from reading import data, it's from mysci.reading. from mysci.printing. So from folder dot .py file, import function. Okay, that's all there. And go ahead and make the same changes to heat index. You're just adding the directory name. And just run one real quick just to make sure it works. Okay, great. One last git add. Creating the mysci package. Okay, guys, that is all we have time for today. We did a lot of work in code refactoring. We created our first Python package. Hopefully that seemed a little bit easier than you thought before we started today. And we've kind of covered modules. You're familiar with import statements, some more f-string formatting functions, and the files PyCache, Git Ignore, and init.
Julia, I was busy answering a question in the chat, so I wasn't paying attention. Did you import from mysci?
Yes.
In the script? Okay, excellent.
Yes. I'll show you. We import from mysci.
Excellent.
Okay.
Thank you. Sorry about that.
So everyone, please join us in 2 Wednesdays from now on February 10th. And we'll complete the lesson on Python packages, and we'll complete the Your First Python tutorial seminar series. After that, we'll have more episodic or one-off sessions on specific Python tools that you will find very useful. So thank you all for your time, and we will take questions in the chat now.
So one person asked, where will the recordings be available? They will be made available from links in the online Python tutorial website.
Mm-hmm. Once we have the video uploaded, which we now, as of a few days ago, we now have a YouTube channel for Project Pythia, which is a broader learning effort, and I will send out the link to that video in an email, as well as update the website with the correct video links.
Someone asked if you could show the read data.py file again.
Oh yeah, I can do that. Okay. Oh, sorry, I'm again not in the right spot because I have to move into mysci and then look at it. Okay, yeah, so if you were getting error messages in your scripts that were pointing to heat index comp, that line, if the line it was pointing to was this function call, your error was probably in the separate module, the reading.py script. Do you need me to scroll down? Is there a lower part of the function you'd like to see? I could also maybe zoom out to show a little bit more of it, but the font might be smaller.
Said that was good.
Okay.
So someone also asked, should we add init.py to Git Ignore? And I would not advise that. So the __, or sometimes referred to as _ init __.py is a special file that Python needs in that directory in order for Python to know that that directory is to be treated like a Python package. So you need it there, even though it's an empty file. And as Julia said, it is very commonly an empty file, but it doesn't have to be. One thing that we didn't exactly talk about is that whenever you do an import of a module, that module is actually executed. So if you define variables or you actually run code in there, at import time, that file will actually be executed, which is why normally when we have Python files that we want to import, the things in those Python files tend to just be function definitions and maybe the construction of data that we're going to use many times somewhere else. But that happens once at import time, and then all those functions will be defined so that you can access them later. The init.py file is the same. Whenever you import that package or something from that package, that init.py will be executed too. Normally, you don't need anything to be executed, and so we just leave it blank. But it does have a function that it actually tells Python that this directory isn't just a directory, treated like it's a Python package. Any other questions? Someone asked to please show the wind chill script again. I think that's the wind chill comp.py script.
Okay, on it. Do you have any questions about a specific part of the script, or just wanted to be able to compare specific characters?
Someone asked a good question. I haven't received anything about the wind chill script yet, but someone asked a question about why we use touch. Strictly speaking, if you don't use touch to create the file initially, Nano or VI or whatever text editor you happen to use will automatically create the file if it doesn't exist. So you don't really need those touch lines. But for example, when you're creating the init.py file, which is literally an empty file, touch is kind of convenient. But no, you don't need it. You could have just skipped those touch calls and just created it with your text editor. Anybody else with questions?
Okay, thank you, everybody.
Yes, thank you all.
Hopefully see you again.
Yep, thanks everybody for being fantastic in the chat too. See you in 2 weeks.